All right, now we're graphing lines in standard form with me, Mr. Hain. And our essential question for this video is, how can I graph lines in standard form? How much more straightforward can I get? Well, pause the video, make sure you have that essential question written down, and when you're ready to go ahead and hit play. I'll be here when you get back. Sweet. Let's get some worked examples. Let's take a look at example A. All right. So I've got 4x plus y equals 0. So I'm looking at this equation and I know I can actually just isolate y. So I'm going to move the 4x to the other side using the opposite operation. So this is a positive 4x, so I use subtraction. And that gives me y equals negative 4x plus 0. And that lets me know something. The b, or the y-intercept, is 0. And I've got my y-intercept right here hanging out at the origin. And the m, my slope, is negative 4 over 1. Cool. Because it's negative, that means I know I have to go down. So down 4 over 1. I got my second dot. I have two dots just like in kindergarten. I'm going to connect them. Kaboom. There you go. So I have a line from two dots, both given from my example A. When I put it into slope-intercept form, definitely a method that you can use to go ahead and solve and graph lines in standard form. But when do I use this? I use this because y is isolated, easily isolated, and it has no coefficient. So as you see, there's a small note here. If you have my notes in front of you, you can work example F just like example A because y is isolated. But that brings us to example B. See, B, I need to find out different things. I'm going to find out the x-intercept. The reason is I'm going to use intercepts is because the y has a variable in front of it. So it has a coefficient in front of it. I'm sorry. The y has a coefficient of negative 6. So that means I take my x-intercept, y is equal to 0. When y is equal to 0, that means I can actually eliminate that from my equation, because negative 6 times 0 is 0. That leaves me with 10x equals negative 30. I just use the opposite operation and I divide by 10. That gets me x is equal to negative 3. So on my x-axis, I can, kaboom, put a dot right there. Awesome. So now I have one dot. That was from the x-intercept. So I can find the next point by finding the y-intercept. And of course, that means x is equal to 0. That eliminates the 10 times 0, which is 0, leaving me with negative 6y is equal to negative 30. If I divide both sides by the coefficient of y, which is, if you said negative 6, you are correct, then skadoosh, I know my y is equal to positive 5. So I have my second dot, y is equal to positive 5. I have two dots just like in kindergarten. I can connect them, and kaboom, I've got my line. Now, if you have my notes, you can solve examples D and E like this because y has a coefficient. So be sure as you are working through that you are just using the correct method, whether it be to isolate and find the equation of the line in slope-intercept form by isolating y, which is what we did in example A, or by finding the x and y intercepts, which is what we did in example B. All right, so this is a lot of information that I threw up there very quickly. Please pause the video if you are at home or in a classroom. Make sure that these are worked out just like this and all the work is shown on your notes, especially if you're in my room. Go ahead and pause that video. I'll be here when you get back. And we're back. Cool. So example D can be solved just like example B. All right, cool. So I'm going to not do example D because you don't want the answer to that. But example C is way different. It just has an x. What the heck am I supposed to do with x equals 5? Well, all I know is that I have a point at x equals 5. Because I know it's a line, I know that I actually have a graph of a line passing directly through x equals 5. It is vertical. So when I have x equals a number, it is a vertical line passing through that value on the x-axis. X equals 5, dot at 5, vertical line. So the line is vertical when the equation is x equals. When it's y equals, it's kind of like the opposite. So what would that mean? If you said that means there would be a horizontal line passing through it, then yeah, if this was If the example for C was y equals 5, there would be a dot right here at the point 5 on the y-axis, and I would have a horizontal line that passes directly through it. Beautiful. All right, go ahead and pause the video. Make sure you have example C done in your notes. And remember, if you're in my class and have my notes, you can keep on going. And there are even ones on the back to keep you practicing and engaged and doing the math. I'm going to walk through some of the other problems and briefly mention some points about them. Pause the video and before I do the walkthrough. We're back. All right, so example D can be solved like example B. Go ahead and isolate and find those intercepts. Don't worry if you find a fraction, just do your best. Just put it approximately where it should be. It's not that big of a deal. All right, so for E and F, I definitely gave you a hint. F can be solved like example A. E can be solved like example B. First, find the X and Y intercepts. That's what the blanks mean. So find the X and Y intercepts, and then you can graph them. F you can graph using the slope intercept form. It's not a big deal. Or you can do it with X and Y intercepts. And that's it, folks. Write your summary if you're in my class. Make sure your table of contents is updated. And keep doing the math.